right, so we're going to wrap up our final lesson on congruency by looking at our congruency of triangles in the coordinate plane. So we're going to, once again, it's going to connect to all of our shortcuts that we've already talked about. However, how we get to those shortcuts, how we gather that information is what differs. So you can see that we're on Unit 7, all right, or excuse me, Lesson 7 of Unit 7 on page 79. And you can see this takes care of that last standard 17.4. I can use my knowledge of properties and congruence of triangles to solve problems, okay, on the coordinate plane or in the coordinate plane. So here's what we want to do is just kind of get you thinking a little bit about coordinate plane stuff by doing an opener that focuses on the midpoint and the distance between 2 points. So go ahead and pause the video, all right, do those two problems, and then flip it back on, we'll see how you did. All right, so let's look at the work. So remember, when we find the midpoint, we're finding the average of the x value and the average of the y value. So all you have to do is add your x values together, divide by 2, and you get 1/2. All right, add your y values together, divide by 2, you get 2. So the midpoint between 4, -6 and -310 is 1/2, 2. Now, with the distance formula, remember, we're really using the Pythagorean theorem. All right, and A represents the horizontal length. So when I go from 4 to -3, the horizontal leg of that triangle would be 7. And then B represents the vertical change, all right, or the vertical leg of that right triangle. So when I go from -6 to 10, I change 16 units. So then we have 7 squared plus 16 squared equals c squared. And you can see we add everything and we get to the square root of 305 as the distance, all right, between, all right, 4, -6 and -310. Now, so we come back down to the coordinate plane, right? We want to know, and really the midpoint is somewhat important, all right, but it's not really something you'll use, but you will use, all right, the distance formula quite a bit, right? And so then remember, when we find the midpoint, right, it's add your x values of your coordinates, divide by 2, right? Add your y values of your points, divide by 2. So we're finding the average of those. And then just remember that distance is just, right, the Pythagorean, equals, not plus, equals c squared, right? All right, and then this is the horizontal change, and B is the vertical change. And like I said, sometimes it's helpful to also draw those in when you have to use the distance formula, all right, in the coordinate plane. So you can see that horizontal leg and vertical leg, all right? Okay, so now let's go ahead and flip to, all right, page 80. And then remember that we're still using our same, all right, our same shortcut. So we have side, angle, side, all right? So when we think about side, angle, side, right, for side lengths, right, we might have to use the distance formula to find those lengths, right? So if we're going to say that two sides, right, are congruent, we need to know their length, all right? So that means we have to use the distance formula, which is what you just did in the opener, right? Okay, and then when we think about angles, right, we have lots of different ways to find angles, right? So we have vertical angle theorem, right? We can find parallel lines, right? And then that leads to our alternate interior angles, that alternate exterior angles, corresponding angles, right? We can show that we have perpendicular lines, right? And then that shows us that we have right angles, which we know we're congruent, right? So we're still going to do side angle sides the same way, right? But now, once again, how do we get that information, right? Sides, we have to know side length, so distance formula. This is where maybe you could look at and say, ooh, it looks like maybe there's a midpoint, and you could use the midpoint to see, right? But it's probably just as quick just to do the distance formula for each piece and compare those, right? And then for our angles, right, we still have all the same things that we've been talking about, all right, with angles, all right, since the beginning of the year. And that's going to hold true for all, right, of our, okay, for all of our shortcuts, right? So we have side, angle, side, right? Angle, side, angle. We have side, side, side. We have angle, angle, side, right? And then now the one with the hypotenuse leg, right? And I just want to make sure we put an asterisk here, right, is that we have to show we have right triangles first, right? Because we can only use HL if we know we have right triangles. So if you think they look like right angles, or excuse me, right triangles, right, you have to show that the lines are perpendicular, right? Right, which means we need opposite reciprocal slopes. Okay, all right. So remember that you can only use HL if you have a right triangle. So the first thing you have to do to use HL is show that you do in fact have two right triangles, right? Whereas for all of these, the rest of these, you don't have to do so, right? You can just go through and try to find whatever information. Now, once again, technically, if we're in the coordinate plane, you can do side, side, side every time, right? Just find the distance, right? Or the side lengths in the first triangle, find all the side lengths in the second triangle, see that they're all equal, right? Now, that's not necessarily the shortest way, right? The most efficient way, but that is a way that will work every time, all right? So, know that that's always kind of in the back, all right, of your mind if you can, all right? Or if you get lost, that you can always fall back on that. Okay, so now, let's go ahead and jump into an example or two here, all right? And let's look at page 81, and we'll look at problem 1 here, all right? And I'm just going to draw in our triangles here real quick, all right? And then notice what it says on problem 1 as I'm drawing these in. You might want to pause the video and draw them in too, all right? So notice, all right, that it wants us to find or show that these two triangles are congruent by side, side, side. All right, so now we don't have a choice. So it's asking us for a specific method, side, side, side. So what that means is we need to find side lengths. All right, we got to find side lengths. And so when we think about our game plan, right, so when we do side, 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 all right, it's really just going to be distance formula, all right, over and over again, right, 6 times, right? So 3 here, 3 here. All right, so let's just go ahead and get started, right? So let's find, all right, let's just start up here, and let's find the distance of EX, all right? So that's squared, right? And then once again, if I draw in my triangle here, all right, it looks like I have 1, 2, 3, 4, 5, all right? So 5 squared plus, and notice here, it looks like we're in some halves here. So when I look at E, it's at 5.5. When I look at X, it's at 3.5. So I drop down 2 boxes. All right, so you might have to kind of confirm that as you look and kind of go through, right? So then the distance of EX squared would equal to 5 squared plus 4 squared. So that'd be 25 plus 4, so that's 29. So the distance of EX would be the square root of 29. All right, so that's the first one. All right, so now when we go through and we look at this next right here, all right, so I'm going to go with the distance of XD next squared would equal to, and then I'm going to just draw in my right triangle here, and you can see that we only have a distance of 1 there, so 1 squared plus, all right, and then I'm going to go up 1, 2, it looks like 2.5, right, and I can see like when I go from X to D, 3.5 to 1, that definitely is 2 above, 2.5 above, so that would be 2.5 squared. All right, so the distance of XD squared would equal 2. And then if I just go to my calculator here, I'm going to do 2.5 squared. I don't know that right off the top of my head. And I'm going to add 1 to that. So if I do 1 squared plus 2.5 squared, that's 7.25 squared. So the distance of XD, all right, would equal the square root of 7.25. All right, so we're just kind of just making our way, right? And you can see that this works every time, but it's not necessarily the shortest method, right? Okay, so now let's find this distance here, which is our final triangle here. So the distance of ED squared equals 2, and then I can look here, and it looks like I have a 1, 2, 3, 4 for the length of that horizontal leg. And then it looks like 1, 2, 3, 4.5 for that leg. All right, and then, so 4 squared plus 4.5 squared is 36.25. And so then the distance of ED would be the square root of 36.25. And notice I'm not reducing anything here. All right, this isn't necessarily a great way to leave the answer, but I'm really only comparing them. So I don't really care what the answer is. I just need to be able to see that they are the same. All right, so I can leave it like that because now I'm going to know is, do I have another square root of 29? Do I have another square root of 7.25? Do I have another square root of 36.25, right? All right, so now let's go to our triangle here. All right, and so now let's start with JY right here. So the distance of JY squared equals 2, and I'm just going to quickly draw on that right triangle. I get 1 squared, all right, and then I have 1, 2, 2.5 squared. And what I can see right now is that looks like it's going to match this guy right here, right? So that's 7.25, and then the distance of JY is going to equal the square root of 7.25. So I have a match here and I have a match here. All right, so now let's look at YO. So the distance of YO squared equals, and so if I draw in that right triangle here, it looks like I go over 2 boxes. And then I go down 1, 2, 3, 4, 5. And once again, now that looks like it's going to match right here, right? So distance of YO squared equals to 29. So the distance of segment YO is the square root of 29. Okay, so now I have 2 of my sides. And then our final match here would be JO. All right, so the distance of JO squared equals 2. I go over 1, 2, 3, 4.5. Plus, I'll have to kind of get that out in the margin there. All right, and then it looks like we have a distance of 1, 2, 3, 4. And so once again, that looks like it's going to match what we had for ED. So that's 36.25. So the distance of JO is the square root of 36.25. All right, so now, there we go. So we have 3 sides, right, that match 3 sides. So we know that these triangles are congruent, right? So triangle DEX is congruent to triangle JOY by side, side, side. All right, so just real quick, I'm not going to go through all of number 2 with you, but I'm going to set it up and then just let's talk about it a little bit. So we have -5, 7, -5, 7, and once again, all right, we're going by 2s on your scale, so make sure you pay attention to that. We have 6, 7, so 6, 7 would be right here. And then we have -11, 0, which would be right here. And we have 0, 0 right here. So that's E, A, oh, no, this is R, excuse me. That's R, and this is E, and this is D. All right, so then if I just kind of start connecting these in, so RAD would be this triangle, all right, and then RED would be this triangle here. And notice it wants us to prove this by side, angle, side. All right, and I would say that let's, and just to show you something here, I'm going to just change this, and let's go with angle, side, angle. And I just want to show you this real quick here. And the reason why is this. Notice that both of these triangles share RD, right? So when I think about angle, side, angle, right, I have to have one pair of congruent sides. Well, if they share a side, I don't have to find the distance because I know it's the same, right? Everything is equal to itself. So I know RD is congruent to RD. So I don't have to find the distance if it's congruent to each other. Now, if I want angle, side, angle, what that means is I need to show that angle 1 here is congruent to angle 2, right? And then I need to show that angle 3 is congruent to angle 4. And notice what those are, right? So if I look at RA and ED, I can say that angle 1 and angle 2 are alternate interior angles. So now, if RA and ED are parallel, then I can say that angle 1 is congruent to angle 2. So remember, when we talk about parallel lines, right, we have to know that they have the same slope. So when I look at RA, right, I know the slope of RA is equal to 0. It's a horizontal line. I know the slope, and I wrote that backwards, I should do this. The slope of RA is equal to 0, and I know the slope of ED is equal to 0. All right, so that means that RA is parallel to ED. And then that means that angle 1 is, in fact, congruent to angle 2. And so now I have that angle and that angle. And then you could see that you could do something very similar for RE and AD, which is what I wanted to show you. So I'll let you finish number 2 up and finish 3 and 4 up, and that wraps up our unit on congruency. I will see you in our next unit on trigonometry. Take care.